Okay, this video is on, it's kind of a follow-on from our previous video. On this video, I want to determine what the angle is going to be to find out what our maximum normal stress is going to be. Now to do that, if we think about this, if I take the derivative of this function in respect to theta, so let's take derivative of this, and this was on the x-axis anyway earlier. We did that in the normal. We're going to take the derivative of this, x prime, in respect to d theta. Now when we do that, this is constant, so this goes to 0. Okay, and we'll do this one. That gives me normal x minus normal y over 2. Now multiply it by that. That's going to give me the derivative of the cosine of 2 theta. We're going to do the chain rule. That's going to give me minus sine of 2 theta times 2 plus the shear times the cosine of 2 theta times 2. Alright, so we'll go ahead and simplify that. And that's going to give me the derivative is going to be d over x prime in respect to d theta. It's going to equal to negative 2 actually I won't do the negative. Let's just bring the negative in front. We'll leave the 2 over here. Oh, sorry. So that'd be negative. Oops. Bear with me, sorry. The negative of the normal of x minus the normal y over 2 times 2 times the sine of 2 theta. And then we can say plus 2 times the shear stress times the cosine of 2 theta. Alright. So now if we solve this equation, we can determine what the angle is going to be. Now let me go ahead and move this down here. Okay, so come back again, and what we're going to do here, I'm taking this, I'm going to set this equal to 0. So let's say 0 is equal to negative. And that was supposed to be a 2. It doesn't look like a 2, does it? Let's make it a 2 better. Okay, slide this on down. Keep moving things down here. I'm going to give myself plenty of space here. Just a second. Bear with me here. Move this down too. Give us more space here. Okay, so now I'm going to move this to the other side. When I do that, that gives me minus 2 times the shear here times the cosine of 2 theta is equal to negative my normal x minus normal y, again that's in parentheses, over 2, and times the 2 times the sine of 2 theta. I might as well cancel out the 2's right now. So 2 here will cancel out here, here. Okay, so now what I want to do is I'm going to move the cosine theta over to the other side, divide both sides by cosine 2 theta. Here, so this cancels out here, this cancels out here. My negatives cancel out, my negatives cancel out. Scroll down, move this thing down one more time to give myself some more space. Okay, come back to this equation. Let's see if we can go ahead and simplify this a little bit more. Alright, so now move this down. And let's see what I get when I do that. I will get 2 times my shear over my normal x minus normal y. Is equal to the tangent of 2 theta. Okay, so now what I have an equation here. I can find out what angle, by solving for this, what angle that I'm going to get the maximum normal stress is going to occur, maximum or minimum normal stress is going to occur. Alright, now let's do the second one. Come down to this one. We're going to do almost the same thing here. We're going to take the derivative of this shear in respect to time, and when we do that in respect to in respect to theta. Alright, when we do that, derivative of sine, so this will give me, let's go through this real quickly, over 2. The derivative of this will give me the cosine of 2 theta times 2, doing the chain rule, plus on this the shear, and that's going to give me a minus the sine 2 theta times 2. Okay, and we're going to set that equal to 0. Alright, so let's see what we're going to get here. We can cancel out something here. Our 2 is going to cancel out across here. Alright, we're going to now start moving things around. We'll move this to the other side. Put the 2 back in front here. I got the cosine of 2 theta here. Okay, at this point I'm going to divide everything by the cosine of 2 theta. Both sides. Both sides here. When I do that, they cancel out here, cancel out here. Now let's see what we have here. I have 2. I need to label that as my shear, Tyx. 2 Tyx times the tangent of 2 theta. Just about got it done. Okay, and divide everything by 2 by this. I'll divide this side by 2 by the shear over 2 by the shear stress. And what happens here? You've lost this, you lost this, and now you're down to the tangent of 2 theta. They'll go to minus the normal of x minus the normal y divided by 2 times my shear stress. Okay, now this equation is useful to find the orientation or the angle where you're going to get maximum shear stress. Now one thing to note is that the angle that you're going to hear will be exactly 45 degrees off from the angle you got here. So maximum shear stress will be 45 degrees from the position of an element that is subjected to the principal stresses. And that's a good thing to note. Now, the only other equations you can get from this, and we get this from substitution, I'm not necessarily going to go through the mathematics, but if this equation here, and again it's just substitution, but if you want to find out the principal stresses the max or min principal stresses, then you can say this is going to equal to, that's supposed to be equal to the normal of x plus the normal y over 2 plus or minus the square root of the normal of x minus the normal y over 2. We square that plus the shear squared. Okay? Again, that's going to give us our max and min principal stresses. And again, to note, there will be no shear stresses that will act along the principal axis. Alright, now to get the maximum in-plane shear stress, you can use this equation here, that the max, and that's going to be the in-plane, is going to equal to the square root of normal x minus normal y over 2 squared plus the shear stress okay. Again, that's going to give you the maximum shear stress. Okay, and there's nothing really, I mean, all I'm really doing in doing that is from the previous equations we used, substituting back in these angles. That's all I'm really doing here and here. Okay, so there's the proof. There's the two equations. One's to find the max and min normal stress. This one here, max and min principal stresses, and this one will be find the max shear stress.